Hi, how's everyone doing? My name is Larry Pang, Head of Business Development at IoTeX. We're based in Silicon Valley, and today I'm going to talk to everyone about something that's fairly new, a new paradigm for different blockchain networks to even collaborate. First of all, I want to say congrats to Max on the big SDK release and everyone here at Lisk Center. Thanks for the welcome. I spent a couple of days in Amsterdam already, visiting The Hague yesterday. And it just seems like a very collaborative and very hyper-curious environment that you guys work in. So keep doing what you're doing, and we'll show you a little bit about what we've been up to at IoTeX. Basically, our goal is to build the Internet of trusted things, not just the Internet of Things, where humans, machines, businesses, and dApps can all exchange value and information at a global scale. For those that don't know, I'm just going to run through this very quickly. We combine blockchain, secure hardware, and edge computing to help developers realize different privacy and IoT-related applications. We were founded in 2017, did a private sale in February 2018. Earlier this year, we launched our mainnet alpha. We have offices in Silicon Valley, hardware office in Shenzhen, 60 global delegates, including Blockfolio, EliteX, CoinGecko, and some others. And we have different types of innovations. One is our role depost consensus mechanism. It's basically randomized delegated proof of stake. Helps with adding a little decentralization to traditional deposts. We also have our blockchains and blockchain architecture. Much like Lisk, we have kind of this concept of multi-layer blockchain architecture to separate duties. But the thing I wanted to talk to you guys about today is this last piece here around trusted computing. How many privacy developers do we have here? Cool. And how many trusted computing developers do we have here? My man. Cool. So, I'm going to talk to you a little bit about what we're doing at layer 2 in trusted computing and privacy. So, this is just some background for the folks. So, layer 1 versus layer 2, what do people mean by that, right? A lot of people say layer 1 is the infrastructure layer, layer 2 is more of the application-oriented, function-oriented layer. So, at layer 1, you have the hardware, you have data, you have network, and you have consensus. So these are things that all blockchains need, right? At layer 2, we see more things around the application layer. Building blockchains that are more specific to specific applications, right? Just like Genie is focused on machine learning, it needs a specific architecture, a specific set of tools. For our purposes, we try to build our technology to enable people to build IoT and privacy-enabled applications. And the best thing is that the concept of layer 2 is that, as people mentioned earlier, it's generally blockchain agnostic. So what we're talking about today, much like Chainlink provides Oracle data to different blockchain networks, much like Stellar adds scalability to different blockchains like Ethereum, Loom, Lightning Network for Bitcoin, we're really trying to bring capabilities that the entire blockchain industry can eventually use. Oops. So this is kind of a rundown of what I'm going to be talking today. I'm not going to be talking about our root chain. I'm going to be more talking about our first layer 2 chain or side chain. It's called Avo chain. This is really a subchain in our network that enables a concept called trusted computing, we'll dive into later, as well as a concept called trusted data oracles. So that's the topic of my talk today. A small introduction to trusted computing, right? What we're really trying to do with trusted computing is enable the best of both worlds. There's private permission blockchains or consortium blockchains, private blockchains, whatever you want to call it. These are more focused on enabling traceability and trust without exposing data to non-relevant parties. But there's also on the permissionless side, you have, which the goal is enabling trusted interactions between otherwise untrusted parties. So how do we get the best of both worlds? Our answer to this is a permissionless blockchain with privacy-preserving features. So you have the ability to build trust across untrusted parties, but also the ability to selectively share data with different parties. An open private computation platform for the trusted processing of sensitive data. This is just a foundational thing that I need to explain around secure hardware. What do we mean by secure hardware? Everybody has their phone today. Every time you put your fingerprint or it reads your Face ID, that process is being run in something called the Trusted Execution Environment, a TEE. Most devices today have them, but they're closed and they're non-programmable. It basically ensures that any device or any data or process run within this TEE has guaranteed confidentiality and guaranteed integrity. You can think of it as a trusted third party, right? A lot of the trusted third parties we have today are intermediaries that we put our trust and possibly our money into to facilitate and broker transactions between untrusted parties. One thing that is even going on in the traditional IoT world is an explosion of trusted execution environments. Today, generally non-programmable, is lacking a lot of middleware, a lot of SDKs that make it easy to build trusted applications. But our thesis at IoTeX, and something that we've developed in-house, is the concept of TEEs being standard in all devices and programmable. A lot of people think about this in the context of open source hardware. It's coming just like open source software. And the result is what we want to do is collect and process data from multiple data owners or consumers without exposing or leaking any of their underlying information. Just a quick fact around this is a decades-old technology. Intel has their own trusted execution environment technology called SGX, Safeguard Extensions, and that is more of like a cloud server with a trusted execution environment in it. The other part of which we're developing in-house, and we have a little prototype of our in-house hardware, bubble wrapped, is what we call Avo board. So this is our developer board. It uses TrustZone, which is ARM technology. Instead of being more prone to running on servers, this is more for edge devices. It doubles as an IoT gateway, so you can hook up different kinds of IoT sensors and things like that through different wireless modules, Bluetooth, LoRa in the future. So this is what a trusted execution environment is. Why are these needed? In the context of blockchain, trust is everything. I feel like all of us in here are in this room today because we all believe that blockchain can enable trust, right? One thing that's tricky is though, when you're dealing with IoT, it takes so many hops to get from the middle of a desert somewhere to track temperature data all the way to the server that's running your blockchain, right? So we think about trust not only from the context of user-generated transactions, right? If I send any of you guys one token today, there's no way to falsify that. That's a user-generated transaction. But when you're bringing real-world data onto the blockchain, that's a whole different story. You need to make sure that the source, the transfer mechanisms, the connectivity standard it's using, all of those things are not maliciously attacked or they're just secure, right? So we think about this in two ways. One is called a trusted IoT device. Think about any kind of sensor, any kind of IoT device that's Wi-Fi connected. I'm sure some of you have like Wi-Fi toothbrushes and Wi-Fi insert something that doesn't need to be connected to Wi-Fi here. But it's ubiquitous today. It's only going to get cheaper. It's only going to get more and more devices are going to be connected. We also have the concept of a trusted IoT gateway, which kind of links to these different types of trusted IoT devices. Avoboard is an example of a gateway that does that. It's important to note that in the context of IoTeX and in context of blockchain, these types of gateways will be running as full nodes, while the trusted IoT devices will be running as SPV or light nodes, meaning they receive the full version of the blockchain from these gateways. But those hops from trusted IoT device to IoT gateway to IoT cloud is extremely important, especially in the IoT world that IoTeX operates in. So secure hardware is a big part of our project. So we build a layer 1 blockchain. We build different types of layer 2 SDKs and things like that. But this is really a big focus of ours. How do we build open and programmable TEE-based devices today? And our two products so far are a secure supply chain tracker. You can trace and track and trace any asset with full trust. The difference between this and a non-TEE device is that you don't need to have, for example, in what Chainlink does is they have maybe 5 nodes that kind of grab the same piece of data. If they reach consensus on it, then it's trusted, right? After you put it on the blockchain, you don't need to worry about it. It's immutable, it's traceable, you're all good. But if that data is not trusted before you put it on the blockchain, then the trust is already broken, right? So this is kind of one element that we're working on in supply chain space. You define and enforce custom SLAs based on this trusted data. The second part is our secure development board. It's a single board computer for the development and operation of trusted applications. Avo board is just one single version of this, right? And if you think about different types of blockchain networks, Lisk has 101 delegates, IoTeX we have 36, right? Those delegates operate servers all around the world to maintain consensus around the whole network. Our goal with these Avo boards is not just to distribute them to one person, but rather to distribute them to many, many, many people and cryptographically link them to create not only a trusted computing device, but a trusted computing platform, to the point where if you don't even own one of these devices, but you need trusted computing bandwidth, you can access the platform, much like Filecoin does with decentralized storage. So what is trusted computing? I kind of missed that step, right? Trusted computing is the concept of enabling people to compute things without ever worrying about leaking their sensitive and underlying data. You know, the direct use case here, you know, I think Max made a great point here around needing to think about use cases that are tangible and doable today, right? I can talk to you all day about what blockchain and IoT in the future can do for any of these verticals, but that's so far away. How do we break these down into building blocks, right? A lot of people always ask us, what kind of IoT verticals do you operate in? And the answer is a lot of them, because we work on the horizontals, right? What kind of horizontal capabilities do all IoT use cases share? One, you need to authenticate and register your devices, which is definitely a use case of AvaBoard. Two, needing to transact and send the data across devices, machine to machine, in a private manner. And three, you have to ensure that whatever data you distribute outside of your comfort zone or your domain, you can ensure that data is traceable. You know exactly what happened to it. Let me explain a little bit more. So this is kind of a, you know, going from this into this is kind of like university to preschool, right? But let me say, like, I think it's important to really start from the foundational basis, right? Think about any enterprise in the world, or any consumer, or any of you in this world. There's some data that is associated with consumers and enterprises that is generally publicly available, the green area. There's no value to it. You can't sell it, maybe yet, and even if you could sell it, you probably make a penny for that data because it's so ubiquitous. It's nothing special, right? And then you have sensitive data, things that you only choose to share with trusted intermediaries or trusted counterparties. And a lot of this data, if I'm an IoT company today and I want to exchange similar data with a company, I'll go through an intermediary, right? The tricky part is, and the difficult part is, these intermediaries, even though they have trusted in front of them, are you 100% sure they're going to take care of your data? Data breaches kind of point otherwise, right? And then the last bucket is highly sensitive data, proprietary data, things that enterprises would not sell even if they could for the largest amount, because that's their competitive advantage. That's what really is their lifeblood. So the problem statement is, how do we ensure 100% trusted sharing of sensitive data and highly sensitive data? This is kind of another diagram here. So take, for example, you have a party X and a party Y. The example I like to use is we're based in Silicon Valley, so we have a bunch of these autonomous vehicles running around with tons of cameras strapped to them, all collecting data, right? These companies have no incentive or mechanism to share this data today. Why is that? Because IoT as an industry is extremely siloed. You know, a lot of the cloud operators today are focused on data lock-in and vendor lock-in strategies. Once they have your data, they're never letting go of it, and you're never getting off that platform, right? So how do we enable different types of cloud platforms, different types of blockchains, different types of any kind of database to kind of share their data in a meaningful way? If I wanted to run a machine learning algorithm on two sets of competitors' data, who's going to be an intermediary that holds that data and runs that algorithm? Do you trust an intermediary to do it, or would you trust a piece of secure hardware that's guaranteed to be guaranteed integrity and guaranteed confidentiality? So our vision for this is, in the IoTeX network, one thing that we try to do is allow people to spin up and spin down both permissionless subchains and as well as permissioned subchains. So one very practical thing that I think everyone can start to think about today, this is just a model, right? And it applies to many different industries, is rather than having a trusted intermediary hold that data, if you give it to a kind of a trusted server or a trusted device, and you inject an algorithm or kind of some kind of computation into that device, all you have to do is bring the data in, and then you can compute the result. None of these counterparties here, party X never touches party Y's data, party Y's data never touches party X, and the best thing about this is party X and party Y know that their data only exists within this secure element. Just like your fingerprints, just like your face print, right? You trust it because you believe that Apple or whoever is manufacturing these phones are not going to use secure hardware that lets data leak. The other thing is that you can make these layer 2 chains, you can make this specific layer 2 chain permissioned to only X and Y, or maybe Z if you want to do a tri-party kind of agreement. You can spin it up and spin it down at will, and you can add a public key infrastructure around this, meaning you have read and write access. If you ever want to make this inaccessible, and GDPR kind of demands that data doesn't have to be deleted, it just has to be inaccessible, right? So if you shuffle the keys around your permission blockchain, this data that holds even the highest and most sensitive data from party X and party Y, you remove access to that altogether. This is really just the building block that we're trying to pitch, right? If you think about what kind of use cases in the healthcare industry, for example, it's all about medical records, right? Would you want your medical records to be out there in the hands of a trusted intermediary, or would you rather have it kind of living in a closed-off island of a device? I think a lot of these trusted computing and privacy use cases require us to not only think about the technology side of things, but also about the social and cultural dynamics that need to shift, right? How do we put our trust out of Facebook and Apple and Google and all these major players? Their definition of privacy is we're not going to share your data with third-party advertisers, but we're going to hold it for you. Our version of privacy is keeping our data away from Facebook, Apple, and Google and all the big corporations, while also, hopefully, knocking on wood, developing the same user experience that some of those traditional applications offer. This is a more complicated kind of schematic of our private computation engine, which is one of the many use cases of AvoBoard and AvoChain. I'm not going to dig too deep into this, but one other thing I wanted to mention is, we're talking about data that is fully trusted, bringing real-world data into the blockchain. This next part is around trusted data oracles, right? I mentioned Chainlink before. We've actually just announced a partnership with Chainlink to evolve the way they bring real-world data onto the blockchain. The way that Chainlink works is if you need, for example, you're building a supply chain application, you need to figure out, you need to call a FedEx API, right? How are you gonna make sure that that FedEx API data is trusted? The way that currently happens is you have 3 different or n different nodes run the same computation, or they're pulling the same data point from FedEx API. If they all match, then yes, you can add it to the Oracle smart contract, which can then talk to the normal smart contract. This is a great kind of model, but instead of having this very convoluted process of having 5 people run the same process, what we propose is using one piece of secure hardware to run that process for you, or even multiple if you need to make sure that that data point is 100% trusted. So this is kind of a new evolution of trusted data oracles that we're working on with Chainlink, pretty blockchain agnostic. So we are trying to bring secure hardware into the blockchain universe, and there's tons of different use cases that we're still exploring. It's worth noting that this technology is still new. It's not even fully developed in the real world yet, but it's also the most practical use of privacy today. A lot of people think about privacy from transactional privacy, Zcash and Monero. How do we kind of send data without exposing the sender, receiver, and the value. We more focus on computational privacy, which I've kind of explained through trusted computing. So that's kind of my presentation today. Hopefully this kind of sparks new ideas about what the intersection of blockchain and IoT and privacy can do. And happy to talk with anyone that's interested in building full-scale trusted computing applications or just using it to grab data points for their applications. Thank you.